I'll give a presentation into deploying with Kargo. It's a Ansible playbook for deploying Kubernetes. Talk a little bit about Kubernetes architecture and what you can do with it. I have awesome transitions that I don't really like. It's fine. So what do you use Kubernetes for? Well, the whole reason why Kubernetes exists is so you can actually deploy applications and make them available for your consumers. This is not, Amazon Cloud. It's not Google Cloud. It's not Azure. It's for private networks. Running Kubernetes means you have to actually take responsibility for the availability of your hosts, unless you're running a development environment and you don't care about how availability it is. To manage containers means making sure they're available, scheduling them, updating them. So Kubernetes provides a really great interface for loading in definitions of pods and upgrade paths. And of course, you do need to network them together. If they're in an isolated box, they're not very useful. Availability means when one host dies, another host picks up, and the application continues on. And publishing is the same as exposing services. Exposing services means just exposing a network port. There's a whole system of Kubernetes called Ingress, where you can actually add filters, load balancing, and whatnot to give your applications the kind of special treatment they need, like session affinity, header management, and so on. Kubernetes itself is quite different from any other cloud system because it has very minimal requirements. You only need a masters, you need a minion, you need Docker or Rocket, you need some networking plugins, you need to manage certificates, and you need etcd. etcd is a key value store developed by CoreOS. It's really lightweight, really easy to cluster. It just works, which is surprising coming from a world of MySQL, Galera, and so on, Postgres. Master nodes, you only need a few of them. If you add 1,000 masters, they kind of crosstalk and it's not very useful. But minions are the actual nodes that run the workloads. They deploy containers. I'm sure you all know about Docker. Runs containers. Network plugins, there's many available. I could not list them all. There's Calico, Weave, Flannel, the new Canal, which is Flannel plus Calico. There's Romano, and OpenControl, and some others. And then you need certificate management. Kubernetes does TLS authentication between all of its components to verify them. And it doesn't include a transport mechanism for distributing keys. You have to do that sort of on your own. This is not my diagram, but do have a credit for the source, just an idea of what the architecture looks like. There's not much out there. There's just kubelet running on every node. There's an API server. It's what users and nodes use to do most communication. A little bit of overhead for scheduling, controlling. And then they all speak to etcd as the source of truth for all information. And then the nodes themselves use, I have a pointer, don't I? Use kubeproxy for exposing all the services that you would run in pods. The story of deploying Kubernetes is not a simple one. It's actually a huge topic of discussion. There are something like 5 official installers, and they're all quite inadequate, I should say. They're great for development environments, single node, sometimes multi-node, but none of them are really HA or high available. There is one that's salt-based. It's okay, but its main downside is it's not very readable. And it's poorly maintained, actually. And since you need to display to multiple nodes and run commands in different orders, you do need orchestration. It's not as simple as SSH node 1, run this command, node 2, node 3, and you're done. It's actually a special dance, so to speak. And then everyone has their own personal preferences in what they should use to deploy with. Raw shell scripts, something written natively in Go, Puppet, Ansible, Chef, Salt, so on. And lastly, there's the idea of containerized Kubernetes, which means you run systemd units to manage your components because you can't do Kubernetes in Kubernetes safely, reliably yet today. So you have to use systemd, and using that to manage Docker containers isn't the easiest thing in the world, and there's a whole bunch of approaches to that. So I'm here to talk about Kargo. It's one of the approaches. I like to think it's a good one. We treat it as realistic because it's broken down into several sections. It covers every component. It covers all the major operating systems. It covers 3 of the networking plugins that are available. And it's very readable, very easy to debug. So I like to think it's a good approach. So first, Ansible requires Ansible 2.1. Cross-platform means Fedora, RHEL, CentOS, Ubuntu, 14.04, 16.6.04, Trusty, Xenial, Debian, CoreOS. So it works everywhere that most people are using. Sorry for you, Arch OS users and Chromebook users. It doesn't cover that. And containerize everything means every component, the API server, the kubelet, the proxy, the scheduler, and etcd itself are all running in containers. That makes it easy to distribute. You don't have to manage versions of packages on each OS. You just have to know where the container is, and it runs everywhere. That's a big win, and it makes cross-platform debugging much simpler. There is one package-based component you need. It's Docker. We're still working on experimental Rocket support, but we're still just Docker-based. And component management of versions is just managing the Docker repo and the Docker tag for each container. And that's it. That's how you do upgrades. You just bump the version in the config. I've already mentioned this, so it's kind of a rehash. Flexibility is nice. It's easy to add a new operating system or a new networking plugin, or if there became another component we needed, it could be done quite easily. And the composability is what we try to strive as being best. It's quite clear where the master node components are, where the minion nodes components, Docker, etcd, and the network plugins. And it runs in a serial order between all of them. Just an idea of what the workflow is. There's a pre-install. There's always a pre-install. But actually, the pre-install is deploy your nodes, like do a bit minimal cloud image of Ubuntu. Xenial is a good example. Just get your nodes up, get their IP addresses, and you have to generate an Ansible inventory. Kargo includes a CLI tool called Kargo CLI. Read it, clever name, where you would put in all your nodes via hostname and IP address. And then once you're deploying, it kind of figures out where all the service addresses, where's etcd live, where's the IP server live. If you specify a load balancer, all the configuration points there. And you need to do some preparation with directories. And then it installs Docker on your hosts, all of them. It force manages all the versions, so you don't have to worry about, oh no, I have the default Docker from Canonical installed, but I need the official Docker one from the Docker repo. No, it upgrades it just fine. And then it deploys etcd. We have a bit of a different etcd deployment in Kargo than you'll see in most setups. I'll get to that a bit later. And then we set up the master which is a series of static pods. Static pods in Kubernetes are some YAML files in a directory, etc. Kubernetes manifests, and these define pods. Normally they're scheduled, but static pods are just started up automatically when kubelet starts. The ones here we have are the proxy, the API server, the controller manager, and the scheduler. So those get set up along with the master, and then we set up the minions to connect afterwards. At the end, they're add-ons. Kubernetes by default, all you get is networking. Your pods can talk, but you can't do DNS resolution. There's no web UI. There's no dashboard. They have to be added on afterwards. So Kargo includes just one add-on, the DNS, kubedns. And it has no configuration. You just install it, and suddenly you can start resolving configuration. Workflow is quite simple in Kargo. When you want to do upgrades, most installers out there don't handle upgrades well because it has to be done in a specific order. You need to upgrade kubelets first, then the controller manager and the scheduler, and then the API server last. So order matters. In some systems it doesn't, but this one, it really does, or else you might lose some workflows that are in progress. So if I was to upgrade from Kubernetes 1.3 to 1.4, which is in beta now, all I need to do is change kube version in my inventory configuration, just like a string, and reapply Ansible. It would do that. So components are all managed through launch scripts or through static pods, and all it does is update the string that says which Docker container it contains. Ansible detects that it was changed, and it'll restart the service appropriately in the right order. So there are some concerns with upgrades. Kubernetes is still quite a new project, like it's only about 1.5 years old. But upgrades work, but it means if one of the main services goes down, the controller manager might decide that that node is no longer useful, and it reschedules all the services. So you might have a huge shuffling going around. But if you can manage to do upgrades really quickly, usually happens, your pods won't be rescheduled. Your applications will stay where they were, and you'll have just a minor hiccup. Usually when you deploy a critical application, you'll deploy multiple copies so that at least one will still working. And that's why it's important to do rolling upgrades. Just upgrade node 1, and then node 2, and then node 3, and then 4, until you're done. It takes longer, but it's safer. And that being said, you're not going to lose any data. You can just still upgrade all at once. It's just you might have a service hiccup. So Kubernetes has an option. If you want to bring a node down for maintenance, you run kubectl cordon that node, and then kubectl drain, and it reschedules all the services off that node. It works pretty well, but it takes some time. So high availability, it's really important because the availability of your Kubernetes cluster depends on your weakest node. Right now, there's some weak points. So all the services talk to etcd for information. It's the only source of persistent data. You can wipe out any one node, and etcd will still manage to replicate itself correctly. But some of the plugins, the networking plugins like Calico, can only talk to one etcd server. So that means you would need a load balancer. But load balancers and virtual IP management is a bit more of a complicated step. It requires some planning. So we decided to use a horizontal scaling approach by adding etcd proxy. Etcd includes its own native proxy that communicates with the cluster of etcd and can decide which nodes are healthy and uses that as the server for each node. I hope that makes sense. But the other downside is that kubelet and kubeproxy can only talk to one kubeAPI server at the current time. So you do need a load balancer if you want high available Kubernetes today. There's a patch on review. It's almost fixed, but soon you'll be able to specify all your masters in a comma-separated list, and you don't need any external tools to do high available Kubernetes, which is good. It should be self-sufficient, high available framework. So Kargo is a fast-moving project. We're doing a lot of development for expanding to Rocket. There's a lot of interest from new developers that are coming in from companies like Red Hat and AT&T who want to see different deployment strategies. They want to not run anything in containers, but pull the files out of containers and then run them as systemd units. Or they want to use OS distribution packages like Red Hat or Ubuntu will build Hypercube, and I didn't tell you what Hypercube is. All the Kubernetes components and install them as packages and then manage them with traditional package managers. So this is another approach. It's more complicated, but it'll give people more choice. And really, the main goal of Kargo is to be a one-size-fits-all type solution, not one specific target that really works well. So really, collaborating with any active members in the community is a big goal for us. And doing the rolling safe upgrades step by step in a more user-friendly fashion rather than some difficult document on how to describe how to do a rolling upgrade would be useful. Terraform is a cloud provisioner, we call it that. That's used for some people. I don't use it myself, but there's a lot of interest in the community for it. So you can use Kargo to pre-provision your nodes and then deploy Kubernetes with it. Right now, cloud support is just limited to deploying on top of OpenStack, Microsoft Azure, Google Cloud, and Amazon Cloud. It's quite easy to work on top of those. There's plans right now to expand to Azure and DigitalOcean. We have some logic that's still in testing to run full end-to-end testing to make sure that the Kubernetes cluster you've built is really capable of every feature. That should be coming next week. They call it end-to-end testing. And support for more add-ons like the dashboard and some more stuff relating to ingress and proxying is in the works. So that's a little bit about Kargo. We're looking for more contributors. It's really a cool growing project that we think is going to be the best choice for developers. For people who want to deploy Kubernetes at scale. We're actually now deploying successfully on 50 nodes. 100 nodes should be in the next 2 weeks. But we're looking to get access to a 1,000-node lab and really see what Kubernetes can do at scale when we deploy it with our schema. Kind of rushed through my slides, but I'm ready for some questions if you guys have any. Guys, oh yeah.
Okay. Questions?
There's one over there.
Yeah, I see. Thanks.
Thank you for the wonderful speech, and I have this question. So supposedly you run like a cluster of Kubernetes and like there's a, okay, say 50 servers, and you notice that some of them misbehave. For example, you deployed a new version and you suspect a misbehavior of a Kubernetes. So you have an idea that you want to roll back one to the older version. Then you want to make it do the major work, but you would also want to send a copy of the network stream to the new. So you have both of them running, and the older one does the job, but you want to compare how new one, how the output of the new one compares to the first old one.
Are you talking about a whole cluster or just one node?
One node.
Well, if you have a node that's misbehaving, there are health checks built into Kubernetes where you can automatically cordon a node if it meets a certain criteria, meaning a certain number of failed starts, or out of memory, or out of disk, or CPU is something wrong. But beyond that, no, it's a manual administrator action, or you would have to use a third-party tool that can actually do this.
Okay. And did you happen to use any tool for this?
No, I'm sorry.
Okay, thanks.
I know they exist, but I'm not at that stage yet for third-party management of Kubernetes. Just what's within the boundaries of Kubernetes itself. Because me and my company at Morantis, we're trying to work on making Kubernetes the best it can be, rather than throwing a bunch of add-ons into it.
Thank you.
We got one there.
Hi. First of all, thank you for your speech. Also, I am the Kargo user. Yes, I tried it a lot. And like the one that I don't like, that it breaks pretty often. So, like master branch, it's got breaking. Like for example, I need to deploy on the Flannel on the CentOS, and like one day it works, and the second day it doesn't work, and third day it got fixed. It would be nice to get some stable tags, like to fix all the platforms and create stable tags so we could rely on it.
I agree. We had a meeting about this last week, actually, and yeah, it was planned for this week to make a stable tag.
Yes,
because
I proposed that on your Slack channel last week.
Okay, you're right. We need a stable branch. It's always a good idea.
Okay, thank you.
Yeah, there were some strange intermittent flannel issues that are now resolved.
Okay. Any additional questions? No? Okay, so thank you, Matthew. It was pleasant exactly to me to listen like a if I'm not mistaken, native speaker.
Yeah, I'm very native.
And it was interesting for me also from another side, because I am iOS developer, and it's like a really different world. And just to make understand how it's like working on the back end, probably at least a little bit. So I think it would be really help me.